We need to get comfortable moving between using metric prefixes and omitting them. Many times it will make the most sense to use a metric prefix, but sometimes it might be easier to do the calculation if we choose a different metric prefix or eliminate it altogether. So in this instance, we're being asked to convert from metric prefixes to abandoning them altogether. What are our base units for each of these three? Well, here we're working in seconds. We have 21 megaseconds because capital M is mega. Here we're in meters. Our base unit is meters, so a unit of length. And our prefix is hecto, H for hecto. And finally, we're looking at liters. The prefix, we call this U shape, mu. It's right down here, and it stands for micro. So we're talking about 89 microliters. Notice that there is one metric prefix, and that's deca, that has either dk or da as its symbol. It's the only metric prefix that has two letters. So if we were working in decameters, for example, you might see dkm or DAM. It's an unusual one. In any case, let's start with 21 megaseconds. Mega, so capital M stands for mega, has the numeric value of 10 to the power of 6, or 1 million. So we're simply going to replace the capital M with its numeric meaning. And 21 megaseconds turns into 21 times 10 to the power of 6 seconds. You might want to convert this to perfect scientific notation where the decimal place should be moved there, and then we'd have 2.1 times 10 to the 7 seconds. But for our purposes, 21 times 10 to the power of 6 seconds is appropriate. 7 hectometers, therefore. Hecto, our lowercase h, has a numerical value of 10 to the power of 2, or 100. So 7 hectometers are 7 times 10 to the power of 2 meters. Or maybe at this point you prefer to write it in ordinary notation. 7 times 10 to the power of 2 would be 700 meters. All of these solutions are appropriate. And finally, 89 microliters. Well, micro is 10 to the power of negative 6. So here we have 89 times 10 to the power of negative 6 liters. Let's go the other way. So here we're given 0.067 meters, and we're asked to convert that to a number using a metric prefix. Our first job here is to turn our ordinary notation, 0.067, into scientific notation. All right, so we've got a small number here. We're going to pick up the decimal place and move it 2 spots to the right so that there is only one non-zero number to the left of the decimal. That gives us 6.7 times 10 to the negative 2. We moved the decimal point 2 steps and we moved it to the right. It is a small number. We're still, of course, in the units of meters. Now we're simply working the other way, having a look at our table. Here, 10 to the power of negative 2, the numeric value, 10 to the power of negative 2, will be replaced by its symbol, in this case, C. So here we have 6.7 centimeters. Try the next one with watts. W is our base unit here. It stands for watts. Let's first convert 2,300 into scientific notation. So I'll pick up the decimal place and move it 1, 2, 3 spots to the left. That gives me 2.3 times 10 to the power of 3 watts. 10 to the power of 3 is kilo, K. So this is 2.3 kilowatts. And finally, 0.0021 liters in scientific notation is 2.1 times 10 to the power of negative 3 liters. And of course, 10 to the power of -3 has the symbol lowercase m, which stands for milli. So here we have 2.1 milliliters. In each case here, it's a much nicer number once we've used the metric prefix, 6.7, 2.3, 2.1, as opposed to 0.0021, where we have to be very clear about how many decimal places we have. So that's one of the benefits of using the metric prefix. It also very quickly gives us an idea of the relative order of magnitude.